Hello everybody, so let's do a real quick recap of what we talked about today. So what we've done the previous days is we've done these things called recursive formulas. And they're good for only finding what the next term is. So today we want to talk about explicit formulas. They're much better. A recursive formula only tells you how to get the next term. So on this one, say just add 3, add 3, add 3, add 3, or on this one, we just multiply by 2, multiply by 2. So you can go back to here, add 3, add 3, add 3, 13, 16, 19, so forth and so on. But if you want the 100th term, it's very difficult. It'll take you a long time. On this one, 3, 6, 12, 24, 48, 96. But if you want to find the 25th term, very difficult. You just have to keep going and going and going. So we have these new formulas. They're called explicit formulas. And the explicit formulas are great because the explicit formulas allow you to get any term. You can find any term. So they're good formulas. They're great formulas. So here is the explicit formula for an arithmetic sequence. It's a of n equals a1, which is your first term, plus n minus 1 times d. Now d is the difference. Okay, how does this work? Well, let's take a look at example. This first example. So I have 1, 4, 7, 10. I know the difference is 3. If I want to find the 100th term, instead of going and making the whole thing, I could jump all the way to the 100th term, all the way up here, by using my formula. So I'm going to plug 100 into my formula. So n, in this case, would be 100. So n is equal to 100, because I'm looking for my 100th term. So I'm going to go a of 100. What is the 100th term? Well, my formula says take a1, which is my first term. a1 is a 1, plus n minus 1. Well, n is 100. 100 minus 1, and then the difference here is 3. I use my calculator, push the buttons, and I get 298. That would be the 100th term, which means we just jump straight to the 100th term. So it's dot, 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 and then 298, okay? Wow, much easier than just having to make everything in between. Well, we also have an explicit form for the geometric sequences. It's different. So it's g of n equals a1 times r. Now r is the multiplier, r is the ratio to the n minus 1 power. That's an exponent to the n minus 1 power, okay? So here's my formula. I'm sorry, here's my sequence. 3, 6, 12, 24, dot, 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 dot. So if I want to make the 25th term, I could continue to make this. 48, 96, 200, anyways, it gets bigger and bigger and bigger. Too big for me. I'd like to jump all the way to the 25th term by using my formula. Well, how does my formula work? Okay, I want the 25th term, so I want g of 25. So what is the 25th term? G of 25 is equal to a1. That's my formula says a1, which is 3, so 3 goes there, times r. Well, the multiplier in this case is times by 2, times by 2, times by 2, right? I'm going to just basically go times by 2, times by 2, times by 2. So r is 2 to the n, which is 25 minus 1. So I put this in my calculator, and this gives me 50,331,648, which is so much easier than making this all the way up to that term. So it jumps us to the 25th term. So this is my geometric sequence. Now today we finished up our Mathia. We did our Mathia on explicit formulas. We had 2 of them on explicit formulas for Mathia. And then we also finished our cutouts. I'll show you our cutouts. We also finished our cutouts, and we put our formulas for all of our cutouts so that now our cutouts are complete. All right. Homework today was page 117, 118, and we'll check that out tomorrow. Okay, that's all I have. Come see me if you ever get confused.